Now let's just move on further towards the next question, which is question number 2, which says that D, E, F are respectively the midpoints of the sides BC, CA, AB of the triangle ABC. So let us suppose if I'm just forming up the figure for this question. So we have the triangle ABC. Let us suppose I'm taking this as ABC, and further it says that we have the midpoints of ABC as nothing but D, E, F. So this is nothing but D, this is nothing but E, and let us suppose this is nothing but F. Let us suppose if I'm joining all these points together, so we have this figure. So at the end we have this particular figure. We have this particular figure at the end, and further it says that we have to show that B, D, E, F is nothing but a parallelogram. So we just need to show that this is nothing but a parallelogram. So let us suppose if I'll just to prove this thing, that this side is parallel to this side and one of the side is equal to each other. So hence this particular quadrilateral will be a parallelogram. So let us suppose if I'm just starting with the very first part. So since we can see over here that D is the midpoint, since D is the midpoint, since D is the midpoint, it implies that we can write BD as nothing but is equal to DC, and furthermore we can say that BD is equal to DC, which is nothing but a half of BC. We can say this particular thing, and furthermore we can say that since E and F are also the midpoints of CA and AB sides, then it implies that EF should be parallel to BC by the midpoint theorem. We know about the midpoint theorem that whenever we have a line joining the two midpoints of the two sides of the triangle, then it is always parallel to the third side. So using this particular concept, I can just say that this side is parallel to the whole side BC, and it implies that EF is parallel to BD. Means if it is parallel to the whole side BC, then it is also parallel to a part of it. So we can say that the side parallel to the whole is also parallel to a part of it. So hence, since we know that since BD is a part of BC, so it implies that if it is parallel to the whole side, then it is also parallel to this side. So hence it is proved that first of all this side is parallel to this side. Now furthermore, we just have to prove that one of the side is actually equal to each other. So we just need to prove that BD is equal to CE not CE, FE. We just need to prove that these two sides are actually is equal to each other, and if we'll be able to prove this thing or this side is equal to this side, then this will be nothing but a parallelogram. So let us suppose if I am just using a concept over here that if we have this as nothing but EF and we have this as nothing but the whole side, then how we can say that they are equal to each other? Now again we can say that EF is nothing but a half of BC by the midpoint theorem, because we know that whenever we are talking about any particular line segment that is formed by joining the two midpoints of on the two sides of a triangle, then it is always parallel to the third side and it is also half of it. So EF is also half of BC by the midpoint theorem. So since from the very first equation, from the second equation, let us suppose if I am taking it as 2, I am taking it as 3. So we can say that from first and third, we can say that BD BD is actually nothing but is equal to DC, which is nothing but is equal to half of BC, which is nothing but is equal to EF. And using this concept, we can say that BD is nothing but is equal to EF. And if BD is nothing but is equal to EF, let us suppose if I'm calling it as 4, so we can say that from second and 4, EF is parallel to BD and EF is also is equal to BD. It implies one pair of side is equal and parallel, is equal and parallel. It implies BDEF is a parallelogram. It is nothing but a parallelogram. So this is the very first part in which we have to prove that BDEF is exactly a parallelogram which is in between this particular triangle. Now let's just move on further toward the second part, in which we have to prove that the area of this particular triangle is actually is equal to the 1/4 of the whole triangle. So let us suppose if I'm just proceeding on further to the second part using the part 1 concept again, So since we have proved that, since in part 1 we have proved BDEF is a parallelogram, then similarly we can say that DCEF is also a parallelogram, comma, furthermore we can say that AFDC is also a parallelogram. It is also a parallelogram. So as you can see over here, first of all I can say that this is a parallelogram. We can say that this is also a parallelogram. Furthermore, we can say that this is also a parallelogram. So in an order, we have actually the 3 parallelograms over here. I hope you can able to see the 3 parallelograms. We can also say that this is a parallelogram. We have already proved it. Using the same concept, we can say that this is also a parallelogram. Using the same concept again, we can say that this is also a parallelogram. So if they are all the parallelograms, it implies that we know that the parallelograms that are lying on the same base and in between the same parallels, they are always equal in area. So hence we can say that if we are just talking about this particular parallelogram, and if we have this particular parallelogram, then they should definitely be equal in area. And furthermore, if I'm just talking about this particular parallelogram, or if I'm talking about this particular parallelogram, then they are also equal in area. So furthermore, we can say that AFED is also a parallelogram. Moreover, we can say that the area of BDEF should be is equal to the area of EF, or let us suppose if I'm talking about DCEF. Why so? Because they are the parallelograms on the same base and same parallels are equal in areas. We can say about this fact. And similarly we can say that if I'm talking about the area of this parallelogram, that is AFDC, and I'm talking about this parallelogram BFED, they are lying again on the same base and between the same parallels So furthermore, we can say that area of BDEF is just as same as that of the area of AFDC, and furthermore we can also say that this parallelogram area is equal to the area of this particular parallelogram, and furthermore we can say that the area of AFDC is nothing but is equal to the area of DCEF. Means they all are actually is equal to each other. They all are equal to each other. Now furthermore, if I'm just talking about their areas being equal to each other, if their areas are equal to each other, so let's just count the number of the times this particular triangle is actually coming in all of these. So if I'm just talking about this particular triangle, or if I'm talking about in this parallelogram, we have this triangle and we have this triangle. So I'm just concerned about this particular triangle. So this would be nothing but half of this parallelogram. It would be nothing but half of this parallelogram. And furthermore, let us suppose if I'm just talking about the area of the triangle, which is nothing but a DEF. So it should be nothing but a half of the area of the parallelogram, which is nothing but BDEF, because we already know that whenever we have a triangle which is lying on the same base and in between the same parallel, means we have a triangle and a parallelogram lying on the same base and between the same parallel, then the area of the triangle is always half of that of the parallelogram. So using this concept, we can say that this is equal to this. Moreover, we can say that area of the triangle, we can say that the area of a triangle for the DEF, it is DEF, is nothing but again half of the area of it is nothing but again half of the area of the parallelogram, which is nothing but FECD. Furthermore, we can say that the area of the triangle DEF is nothing but half of that of the area of AFDE. AFDE means this is nothing but half of this, this is nothing but half of this, again this is nothing but half of this particular area. So we can say that if I'm just talking about this particular area only, it implies that the area of this triangle should be equal to the area of this triangle, which should be equal to area of this triangle, which should be equal to area of this triangle. Means we have all these triangles which are equal to each other, which implies that the sum of the areas of a whole should be equal to the area of the whole triangle, that is nothing but ABC, and this is nothing but the fourth portion, because as you can see over here we have the four triangles 1, 2, 3, 4, and this is nothing but 1/4 of the whole triangle, which is nothing but ABC. Now here we can see that area of DEF is half of this, area of this is half of this, and area of this is nothing but half of this, which implies that the area of the triangle DEF should be equal to the area of the triangle FBD, which should be equal to the area of the triangle EDC, which should be equal to the area of the triangle AFE, and hence it implies that the areas of all are equal to each other. Means the sum of all should be nothing but is equal to the sum of all, that is area of the triangle DEF plus the area of the triangle FBD plus the area of the triangle EDC plus the area of the triangle AFE should be nothing but is equal to the area of the whole triangle ABC, and if it is equal to the area of whole triangle, then it is written as area of DEF, which is 4 times, because all of their areas are equal to each other from this particular equation. It implies that it is equal to the area of the triangle ABC. Let us suppose if I am calling it as the equation number 5, from 5 we can say this. So it implies that the area of the triangle DEF is nothing but 1/4 of the area of the triangle ABC. And this is exactly that we have to prove in this particular question, that area of DEF is actually nothing but is equal to 1/4 of the area of ABC. So hence at the end we have proved over here that in the very first part we have BDEF is a parallelogram, and in the second part we have area of of DEF is 1/4 of ABC. So using the midpoint theorem and the other concepts, we have proved the two parts over here. So this is all about the question number 2.